So in this video, we're going to take a look at Pythagoras' theorem and explain how to use it. So Pythagoras' theorem is only for triangles and it is only for right angle triangles. Now, before we get started, it's really important we identify which of the sides of the triangle is the hypotenuse. And if we have a right angle, like in this case here, the hypotenuse is the side that does not touch the right angle. Now, in these examples, we'll be labeling it with a C, but we could always do it with a H for hypotenuse. As long as we've got it identified, we can use Pythagoras' theorem, because Pythagoras' theorem states that the value of C squared is going to be A squared, the value of one of those sides, those sort of sides that touch the right angle, plus the other one squared as well. Okay, so let's see some examples about how this could work. So here is a triangle. We've got to find that side there labeled H. So we can first of all start, let's label. So clearly the A and the B, and I've purposefully done them in any old order. It doesn't matter which way round we call the A and the B, can be the two sides that always touch the right angle. But we must make sure that the C from Pythagoras' theorem is always that hypotenuse. That's why it's really important. So H, I'm labeling it as C. So if we started with Pythagoras, which says that A squared plus B squared equals C squared, let's swap in those numbers, right? Because of course A is 7, so 7 squared plus 8 squared is going to be equal to H squared. Now, from there, we can start doing some math, because 7 squared is 49 and 8 squared is 64. So we can actually work those out. There they are. And then, of course, we can add them up. Well, 49 plus 64 is 113. So if I know that H squared is 113, I can square root that to find H. So H is going to be 10.6. Now, we are in meters in that question, so we better write the meters sign. H equals 10.6 meters. Okay, let's have a look at another example. So in this case, we're asked to calculate the length of the diagonal of the rectangle. So let's draw that diagonal in. So a diagonal means going from corner to corner. So we're looking at that length there. Now, of course, you can clearly see this makes a right angle triangle. So let's draw up that right angle triangle. Okay, and so therefore we are looking to find that hypotenuse again. So let's label it H. Let's label this A and B, because they're the sides that touch the right angle. And again, let's write out A squared plus B squared equals C squared. There's Pythagoras. So substituting in again, we can say that 8 squared plus 16 squared is equal to H squared. Now, 8 squared is 64. 16 squared is 256. So now we can add those two together. We're going to have 320 is equal to H squared. And again, don't forget, you need to square root this to find H. So if we square root this, we're going to have 17.9. Now, our units for this one were in centimeters. So it's important that we write ours in centimeters too. 17.9 centimeters is the length of that diagonal. Now, let's go on to a different example. Now, this is very different because this time we haven't got the hypotenuse as the missing number. We've got either A or B, one of those sides that's next to that right angle. Now, when we are dealing with this, we need to make sure we still label it up in the same way. So we have this is our C, okay? We can say that that is A and that is B. So we must still label the hypotenuse as C. So if I'm writing out Pythagoras as a starting point, again, then I'm going to have A squared plus B squared is equal to C squared. And we're going to substitute in exactly the same way. X squared for A squared plus 24 squared is equal to 26 squared. And this time it's going to be a little different because we've got that missing variable on the left rather than the right. So 24 squared is 576. 26 squared is 676. So from this point, we treat this like an equation. We're trying to undo it to find out what the x is. So we are going to take 576 from both sides. Now, if we do that, we are going to be left with x squared is equal to 100. And now what we can do is we can square root both sides to find out what x is. X is equal to 10. Now, we were originally in centimeters, so of course we are in centimeters here. X is 10 centimeters. Let's carry on. Now, another question. This time we're asked to find the perpendicular height of this isosceles triangle. So let's be clear about this. Perpendicular height means the height directly straight up, perpendicular to that base. And of course it means 90 degrees. So again, what we've got is we've got a right-hand triangle. So I could either draw mine on the left or the right of that line, but there it is. I'll do it on the left. And let's label up the sides. So let's call the missing sides, well, the 6 centimeters in this case is the hypotenuse. So I'm going to call that C. The thing we're trying to find, let's just call it X. Okay. Well, that's like an A or a B, isn't it? Right. So we'll call it A. Now, the base, though, is not 4. It's half the distance, isn't it? So it's 2 centimeters. So we'll call it B and we'll make sure we mention that it's 2 centimeters. So again, A squared plus B squared equals C squared. So put these values in. X squared plus 2 squared equals 6 squared. So X squared plus 4 equals 36. Well, that is going to mean that X squared is 32. So if I do 32 and I square root it, I'm going to get x. X is 5.66 centimeters. Okay, let's do one final example and then we will finish this video. So a hiker walks 300 meters due north and then 400 meters due east. How far is the hiker now from their starting position? So we're going to need to do a little diagram to help us understand this. So let's imagine this cross is the starting position and we are looking down on a sort of plan view at this hiker. So if I'm going to be walking north 300, I'm going to imagine that's going up and I've got 300 meters there. And then I'm going to go east 400 meters. So that might look a little bit like that. Okay, 400 meters east. And of course, that means if I'm going north then east, I've got a right angle triangle in there. Now, we're asked to find out how far away it is from that finish position that I've labeled with a blue cross from that start position, which was the red cross. And of course, we're looking to find that length there that I've just written out in blue. So again, let's label up the sides. We've got the A and the B are the ones touching the right angle. The C is the thing we're trying to find. It's the hypotenuse. So we've got A squared plus B squared equals C squared. So I've got 300 squared plus 400 squared equals C squared. Well, if I work this out, 300 squared is 90,000 and 400 squared is 160,000 equals C squared. So if I add these up, I'm going to have 250,000 equals C squared. So if I get the calculator out and I type in 250,000 and I square root that, I'm going to get that C is 500 meters. There we go. Okay, I hope that's helped you to understand how to use Pythagoras' theorem in lots of context to find any side.